Hello and welcome to my tutorial on how to do a four-look last layer. Now, a four-look last layer is basically a technique you can apply to the Rubik's Cube to basically solve the last layer with four looks. And it's pretty much just self-explanatory due to the fact that it's really in the name. Now, if you know the beginner's method, which I would recommend you actually know before you watch this tutorial, and if you don't already know it, there's a link in the description. But basically, anyway, back to this. That if you do know the beginner's method, you'll have to go through a good few looks to basically orientate and permute pieces in order to solve this. Now, if you do know the beginner's method, which you should do, you'll know that there's two looks for the edges to orientate the edges, then three looks to permute to orientate the corners, then two to permute the corners, and then another two to permute the edges. In total, there's 9 looks. So as you may guess, it cuts down the amount of looks by a lot. Now, at times, if you're lucky, you might get 4 looks or less if you're lucky with the beginner's method, but there's a greater chance you will not have to go any more than 4 looks for the last layer with the 4-look last layer. So I'm just going to show you an example there of 4-look last layer. So the first thing is I'd look to see, do I need to orientate my edges? In this case I do. So this is my first look, and it orientates all the edges. So that's look 1. Second look, I would see the pattern that the corners make to know which algorithm I need to use to orientate them. So I'd go ahead and do that algorithm. So there you can see that pretty much orientates the corners. So that's look 2. Next we'd permute the corners. So what I do here then is pretty much I would see if I can recognize the case and go ahead and I do that, thus solving the pretty much corners. Then finally I would go ahead to permute my edges. So as you can see, I didn't need to look any more than 4 times in order to actually solve that. So that's basically what you can actually achieve using 4-look last layer, and that's basically it. So let's get started with some of the cases you can get in 4-look last layer. Okay, so the first bit of 4-look last layer we're going to cover is 2-look OLL. Now 2-look OLL basically just covers the orientation stages, and it just involves, as you may guess, orientating the edges and then the corners. So we're going to cover the edges first, due to the fact that everybody does it that way, and it's just a lot easier. So let's just get started with the edges. So when you eventually have completed the first 2 layers, you're going to get onto the edges next, and there's going to be 3 different cases you can usually come across, but unless you have all edges orientated, you can skip to orientating the corners. So the first case you can get when you are orientating the edges is where you have 2 edges that are opposite each other. Now technically you can hold it, technically you have to hold it this way, okay, so that they're on the left and the right, and it can be also this way, so it's pretty much the same orientation as long as they're left and right of each other. And this is pretty much basically the exact same case as the beginner's method. Okay, so if you know this from the beginner's method, this should be incredibly easy, and you shouldn't have trouble with it. Just don't forget that you can't, that you shouldn't really hold it like this if you're doing the algorithm. So always hold it with the 2 edges on the left and right. And as you may remember, the algorithm is F or U, 4 prime, U prime, F prime. And if I went a little fast for you, just go over and over that case until you completely understand it. Even though I really doubt you don't need that long, because first of all, it's an easy case with an easy algorithm, and you should already know it from the beginner's method. Okay, so let's go on to the next case there. Okay, so the next case you can get is where you also have 2 edges, but instead of them being opposite each other, they are now adjacent to each other. Okay, so they're adjacent, no longer opposite. Now when you have this case, instead of them, you need to have it in such a way that one of the edges is in the back, is on the back layer really, and the other one is on the left layer. So you never want to have any edges here. Okay, so do not have any edges here if you have two adjacent edges. Okay, now if you already, since in my previous case I went over the opposite edges and how you use F or U and so on and so on, well, if you know the algorithm, it's actually the reverse of the reverse of that algorithm is pretty much the algorithm to solve this one. So F, U, or U prime, or prime, F prime. Okay, so that is literally the reverse of the algorithm for the first case. So those two cases should be very easy to learn off, and I wouldn't see why you wouldn't really learn it very quickly, because it is such an easy case and very easy to do. So let's move on to the third and final edge orientation case. Okay, so the third and final case you can get when orientating the edges is where you have no edges orientated at all. So for this you can you can basically have the top layer in any way you want. It doesn't really matter due to the fact that all the edges are going to be disoriented the exact same way. Alright, so just doesn't really matter which way you hold it. So the algorithm that is going to be used for this is going to be a small f, so it's a double turn there, or u, or prime, u prime, small f prime, u, f, or u, or prime, u prime, f prime. Okay, so as you can see, that just does all the edge orientation there. Now if you are already on, now just by understanding the algorithm for the first case, as I said, it should be extremely easy to understand the second case, and it will also be easy enough to understand the third case due to the fact it's pretty much the first part is using just double layer turn versions of F, so that should be very easy to understand how to do. And then the last part of that algorithm is pretty much doing that case. So all those cases are pretty much very similar to each other and should be very easy to understand. So let's move on to the next bit of 2look OLL. Okay, so the next bit of 4look last layer is orientating the corners. Now this stage basically has 7 different cases, and they will be kind of a bit harder than the cases the cases you'll get when orientating the edges. So the first one we're going to cover is where we have no orientated corners at all. But we do, however, have what are called adjacent pairs on the sides. And basically adjacent pairs are pretty much where you have two corners facing you and the stickers are the same, right? So this is basically an adjacent pair. If another adjacent pair could be where they say these two are green or these two are blue, all that sort of stuff. As long as these two will be the same on a face, they're adjacent pairs. So if you have two of them and that are opposite each other, so one here and another one here on the opposite side, then this is pretty much going to be this case, and there's two algorithms that you can do. Now the first one that you apply to it is the first one basically is applied when you want to hold basically when you have an adjacent pair facing you. Okay. The other one we can use is where we have the adjacent pairs facing to our sides. Okay, so one algorithm will solve it this way, the other like this. Now we're just going to cover this one because it's actually easy and you would have seen the algorithm before. So you do F or U or prime U prime or U or prime U prime and or U or prime U prime F prime. And literally that is the exact same case, sorry, not the exact same case, the exact same algorithm that you would use for orientating opposite edges when doing edge orientation. And it's just mainly the or U or prime U prime part being done 3 times. So that should be an easy algorithm to learn off. So basically you shouldn't have any trouble whatsoever with actually that version of the case. Now I'm just going to set up that case again to show you the other algorithm. Okay, so this time we are facing to the left and to the right. So we are looking at not looking at any adjacent pairs here. Yellow wise, I know these are an adjacent pair, but we are only concentrating on yellow for the while, so don't worry about if these are the same color or not. But anyway, so you have the adjacent pairs on the left and the right, and what you do here is or u or prime u or u prime or prime u or u2 or prime, and there we go. So just you can learn off one of them or both of them, it's really up to you, and you do have a slight advantage if you know both, so that it can come in one or two orientations again, and you just choose the algorithm that suits it. So that's the first case, and let's move on to the next one. Okay, so for this case we have no orientated corners at all. Now this case is very similar to the previous case, because as you can see there is two adjacent pairs right here. However, on the other side we don't have an adjacent pair, but we have what's called an opposite pair. And basically what this is there's two corners adjacent to each other, and they share one color. Really, you know, don't worry about the top colors here. Just mainly in this case, due to the fact we're solving the yellow face, that we're going to look up for yellow stickers. So in this case, the two yellows are opposite each other, but in this case we would call it opposite pairs. You know, because yeah, the two colors that we're looking for are on opposite faces. Okay, so adjacent pair, opposite pair. So we want to hold the cube with the adjacent pair on the left and do the following algorithm: or u2 or 2, u prime or 2, u prime or 2, u2 or. Alright, so that's that case. So just practice that, and it shouldn't take you long, and let's go on to the next case. Okay, so for this case we only have one orientated corner, and if you look on all the sides that have yellow stickers on them, you'll notice that they're all in the top right on their respective faces. Okay, so to do this case, what you're going to want to do is you're going to hold the one corner in the bottom right of the top face. Okay, so one corner, and all the sides, all the stickers on the sides are in the top right of their respective faces. Hold the one corner in the bottom right. So the algorithm to solve this case is or prime u2 or u or prime u or. Okay, so for this case we also have one orientated corner, and this is very similar to the previous case. However, in the previous case each of the yellow stickers were in the top right of their respective faces. However, this time they're in the top left. And now this one, this case and the previous case do look very similar, and they both have very similar algorithms to solve them. So it may take a little bit of time, but you'll have to take your own pace on learning the difference between the two cases. So hopefully it shouldn't take too long to understand the difference between the two cases and their algorithms, basically. So the algorithm for this case is or u2 or prime u prime or u prime or prime. Okay, so there we go. Okay, so for this case we have two orientated edges that are adjacent, and the other two unorientated edges are on the same face, so adjacent pairs. So an adjacent pair really. So solved adjacent corners and twisted or unorientated, whatever you want to call it, adjacent pairs. So you want to hold the Rubik's cube so that the the adjacent pairs facing you, and do or 2 D or prime u2 or d prime or prime u2 or prime. And there we go. Okay, so for this case we also have two orientated edges which are also adjacent to each other, But however, instead of having an adjacent pair, we now have an opposite pair. Okay, so when you have this case, you want to have the sort of, if you want to call either way, either one of these two is either the solved pair on the solved corners on the left, or an opposite pair on the right. Either one, both of them will basically mean the same thing. You want to have basically either, I'm just going to say have the opposite pair on the right, and do the following algorithm: small l prime, u prime, l, u, or u prime, l prime, u. And there we go. Okay, so the final type of case you can get is where you also have two orientated corners, however instead they are opposite each other. Now you have to hold the two corners in the top left and the bottom right of the top face. So this means you can either hold it like this or even like this. However, you don't want any yellow stickers to be in the front, like this one. So we're always going to hold it like this, okay? So no yellow stickers, okay? So these two corners, no yellow stickers, okay? And then do the following algorithm: 4 prime, f prime, l prime, f, or f prime, l, f. And that solves the yellow face. So basically that just covers all the orientation cases. Just keep on watching over them. If you are still a bit confused, even leave a comment even if you are confused as well anyway. And just practice away at the algorithms, and let's move on to the permutations. Okay, so now we're going to move on to the next bit of for-look last layer, and this stage is going to be 2-look PLL. Now 2-look PLL is basically solving the corners and the edges properly, so they're actually being permuted. So they're being put into their correct positions in relation to each other. So first of all, the corners is what we're going to start off with. Usually, if you already have them solved, you can skip to the next stage, which is permuting the edges. And to know that you need to permute them is that every single side of the top layer will have an adjacent pair. However, we only have one, so we are not going to be skipping on to the next stage. So mainly you'll come across two cases when you need to permute the corners. And the first case is this type, where you only have one adjacent pair. Now to do this case, you want to hold the adjacent pair on the right side and do the following algorithm: x, or 2, d2, or u, or prime, d2, or u prime, or prime. And now, as you can see, the edges, the corners are pretty much solved. So it's pretty much an adjacent pair on every single side. Okay, so the other type of case we can come across is where we have no adjacent pairs whatsoever. Now, because of this, we can literally hold the cube in any way we want, because there's no adjacent pairs to tell us what way we have to hold it at all. Now, basically, when you have no adjacent pairs, what the algorithm will do is swap over two opposite corners. So at least this is better, instead of having to do, you know, an algorithm that'll swap adjacents and then adjacents again. So it'll, you know, cut down the amount of times you have to do the algorithm by twice. So this algorithm at least will just be able to swap over two opposite edges. Well, it's corners, sorry, corners. And the corners are these two, okay? So the algorithm to do this is f, or u prime, or prime, u prime, or u, or prime, f prime, or u, or prime, u prime, or prime, f, or f prime. So it's fairly long of an algorithm, but so it'll take some time to get used to, but eventually you'll know the algorithm, hopefully off by heart, and then you can just use one of two algorithms to do it. So keep on practicing those two algorithms, and you'll be able to permute the corners in shorter time. Okay, so let's move on to edges. Okay, so when you're permuting the edges, you can come into one of four cases. Now, one of the cases you can have is where you only have one edge solved, so that you just need to sort of cycle as it's called, 3 edges, and this is the first type where the edges need to go clockwise, because this is green, which needs to go here. This is red, so it needs to go here. Blue, it needs to go here. So it's going in this motion, which is clockwise. Now, in my opinion, that when you're doing a case like this, you don't really need to worry about the direction. It's, in my opinion, it's just you know, trying to sort out if this color is the color opposite or adjacent to this color. Because if it's opposite, it's going over to here and thus following a clockwise motion. If it's opposite, it's going to here, going anti-clockwise, and we'll cover that in the next case. So if this color here, if these two colors are opposite, then what you want to do is have the solved edge at the front and do or prime u, or prime u prime, or prime u prime, or prime u, or u, or 2. Okay, so that solves the cube there. Okay, so the next case we can come across is very similar to the previous case. We have one solved edge and we have 3 edges that need to be cycled. Now, in the previous case, this color here was opposite to this, meaning it went in this direction, aka clockwise. However, this time it's adjacent, so it's going to go in this direction, aka counterclockwise. Now, as I said, that in order to know which algorithm you're going to use, it depends on if these two are opposite or adjacent. Now, because these are adjacent, what we're going to do is we're going to do the following algorithm, keeping this edge here on the front. Okay, so the solved edge on the front. Or 2, u prime, or prime, u prime, or u, or u, or u prime, or. And there we go. Okay, so another type of case we can come across is where we have no edges solved whatsoever. Now, the one thing you do notice about all of these edges that we need to solve is that they are all opposite the faces that they are on. So basically what this means is that we need to swap over opposite edges like so. Now to do this, just hold your cube in any way you want. I'm just going to do this one since I just stopped it on this just for randomly. And the algorithm you're going to do to solve this case is m2 u, m2 u2, m2 u, m2. Okay, so this is the final case where we have no edges solved at all. Now, if you look at two faces such as these two, you'll notice that this needs to go here and this needs to go here. Even the same on these two. So we're kind of swapping over adjacent edges, so two pairs of adjacent edges. Now, the way to hold it is you want to have one of the edges that needs to be solved on the front, and that edge that's on the front needs to have the face it's going to on the right. Okay, so in this case we have the orange edge on the front and we have the orange face on the right. We can't do something like this where, say, we have the red face on the front with the blue, so therefore we have the blue edge on the front, which needs to go to the blue face that's on the left, because the following algorithm doesn't allow you just to do just to swap over these two, because it's going to swap over these and these. Okay, so we're going to keep the edge pairs like so. Okay, so always have the edge, the faces that will have edges swapping on the front and the right. Okay, and the following algorithm is how to solve this case: m2 u, m2 u, m prime u2, m2 u2, m prime u2. Okay, so that's basically all the cases you can come across in For Loop Last Layer. So just practice over all of them until you get the hang of it, and you know, just as I said, practice away. And if you get confused on any bit of the algorithms, you can watch back over them, even leave a comment. and I'll try and get back to you as soon as possible. So please like my videos, and let me know if you like my videos and give feedback. And as I said, if you have any questions, leave them in the comments below. And thanks for watching.